C is over midpoint and distance formula, which it's been a while since we've looked at these. You may not remember the exact formula, but I think that if you think about what we're doing when we find the midpoint of something and how we use the distance formula, it'll come back pretty quick. The midpoint is just an average. It's looking for the middle in between two numbers. So if I'm going to average two numbers like x1, y1, x2, y2, I'm going to get my coordinate, the midpoint of that would be the average of the two x's and the average of the two y's. That's pretty straightforward. The distance formula on the coordinate plane is how far apart they are, and so it's simply a derivation of my favorite theorem, which is the Pythagorean theorem, where they've worked it out to figure out how far these are apart. And they do that by taking the square root of the distance between the x's and the distance between the y's, squaring them, square rooting the answer. It's just the Pythagorean theorem. So the distance between the x's squared plus the distance between the y's squared. You add them up, square your answer, distance formula. So instead of going over any details of like practice of how to use these, I feel like you should be pretty comfortable with them. We're going to instead do an application of it. So we're going to show that the following figure is a rectangle. So there's a couple of ways we can do that. We can do that by showing that the four corners are right angles and that the opposite sides are congruent. Okay. It's not a square unless I prove all four sides congruent, but if I can prove that all four corners are right angles, that would be enough information for me. So you could say that A, B, C, D, that AB is perpendicular to BC, because this is a slope of up 2 over 4, and BC is a slope of down 2 over 1, and so opposite reciprocals would make that a right angle. But let's use these here. So how far is it from here to here? So the length of AB is equal to the square root of the difference between my x's. So the difference between my x's is 4 squared, and the difference between my y's is 2 squared, which is going to give us 16 plus 4, 20. Simplify, pulling out our 4 to make 2 root 5. BC, remember we're just stealing our Pythagorean theorem, looking at the distance in our x and the distance in our y. So from 4 to 3 gives me a horizontal change of 1 squared plus vertical change of 2 squared. So 5. Now let's look and see about CD. Horizontal versus vertical. 0 to 4 gives us a change of 4 squared. 0 to 2 gives us a change of 2 squared. Well, if these look the same, I'm pretty much there, right? So I know how it worked out last time, so I'm not going to reinvent the wheel. Now let's get AD over here. All right, AD is vertical change of 2, horizontal change of 1. So same thing as above, 1 squared plus 2 squared is root 5. So okay, opposite sides are congruent. That makes it a parallelogram. And then we also came up with our corners. This one has a slope of positive 1/2. This one has a slope of negative 2 over 1. Positive 1/2. Negative 2 over 1. So I have 4 right angles due to negative reciprocals. So I could write that this is a rectangle due to opposite sides being congruent and the corners creating 90-degree angles because of opposite reciprocal slopes. The other thing we could do on a problem like this is we could find the midpoint between these two and the midpoint between these two. Okay, and if both sets of diagonals bisect each other, that would mean it was a rectangle also, and so, or a rhombus. And so if it's a parallelogram and a rhombus, it's a rectangle. I'd have to think about that. That might not be wrong. But I can find the midpoint here of the two, and if that's the same for everything, that'll make our lives easier. No, it would make it a rectangle. So if the midpoints intersect at the same place, it's a rectangle.